Question number 8 says the functions f and g are defined as follows. We're to calculate f of minus 2. Well, f of minus 2 in f, wherever we see x, we're going to put minus 2. So this is 1 plus 3 times minus 2 over minus 2 minus 1. This is f of minus 2. Up top, I'm going to have 1 minus 6. Down by the bottom, minus 2 minus 1 is minus 3. This is minus 5 up top. Down bottom, minus 3. And negative divided by negative is a positive 5 over 3. F of minus 2 is 5 over 3. Determine a simplified expression for f of g of x. Now, f of g of x is a composite function. Literally, we're going to put g in f. How are we going to do that? We're going to write f, and in f, wherever we see x, we're going to put g. So in f, wherever we see x, we're going to put g, which is 5 minus x, 5 minus x. And we're going to simplify. To simplify the numerator, I'm going to remove the brackets by applying distributive law. To simplify the denominator, 5 minus 1 is 4. So this is 4 minus x. The numerator is going to be 16 minus 3x. The denominator is 4 minus x. That is the answer. This cannot be further simplified. So f of g of x is 16 minus 3x over 4 minus x. We're to derive an expression in terms of x for f inverse x. Now, f of x is equal to 1 plus 3x over x minus 1. Step 1 for finding the inverse, take out f of x and say y. Step 2, we're going to interchange x and y. Step 3, we're going to make y the subject again. So that means I need to have y by itself on the left side. So I'm going to start by cross multiplying. Well, it doesn't matter. X times y minus 1 is equal to 1 times 1 plus 3y, which is 1 plus 3y. Distributive law, xy minus x is equal to 1 plus 3y. Let's get all the y's to one side. So xy minus 3y is equal to x plus 1. Positive 3y on the right goes over to the left and become negative. Negative x on the left goes over to the right and become positive. Y is common on the left. You factor out the y. Then you divide both sides by x minus 3 to get that y is equal to x plus 1 over x minus 3. Then the final step is to take out y and say f inverse of x is equal to x plus 1 over x minus 3. Moving on. All right, B is it looks like traveling graph. The velocity time graph below describes the journey of a car over a period of 70 seconds. The journey is represented in 5 stages labeled I to V. So we can see that for ourselves. We're to complete the following statements. The following statements are during stage 4, the car is traveling at, so we can see stage 4. Stage 4 is the car is moving at 45. You should be able to see that it's in the dead middle between 40 and 50. So that's 45. So it's moving at, car is traveling at a velocity of 45 meters per second with an acceleration of 0. Now, the acceleration is the gradient of the velocity time graph. Now, in stage 4, you have a horizontal line. At stage 4, you have a horizontal line. The gradient of a horizontal line is 0. So the gradient at stage 4 is 0, meaning that the car is moving at a constant speed or a constant velocity. Acceleration is change in velocity over time. Since there's no change in the velocity is constant, the acceleration is 0. Now, the maximum acceleration of the car during the 70 seconds, the maximum acceleration. Now, the maximum acceleration is where you would have the steepest line. Because remember, it is gradient that measures acceleration. The steeper a line, the higher is its gradient. So I think that the gradient is steepest at stage 3. That starts here. This is the point 25, comma 20. It ends here. This is the point 35, 45. So gradient is y2 minus y1 over x2 minus x1. So the acceleration maximum, which is the gradient, is y2 45 minus y1 20, x2 35 minus x1 25. And so this becomes 25 over 10 or 2.5 meters per second square. The unit for acceleration is meters per second square. The maximum acceleration is during stage 3 of the journey, where the acceleration was 2.5 meters per second, or 2.5 meters per second square. Calculate the distance traveled during the first 25 seconds of the journey. Remember, for a velocity time graph, distance traveled is the area under the graph. So this is 25 after 25 seconds. And the area here is the area under the graph for the first 25 seconds. The shape is a trapezium. So up top is 10. Down here is 25. And the height over here is 20. So this is A, this is B, and this is H. So the distance is equal to area so the shape is a trapezium. So the formula for the area is a half A plus B times H. A and B are the lengths of the two parallel sides. So that's a half 10 plus 25 times the height of the trapezium, which is 20. Well, a half of 20 is 10. So this is 35 times 10. The distance traveled in the first 25 seconds of the journey is 350 meters. Stay with me. Whoa. I thought that there was more, but that's the end of the question.